Hi guys, welcome to Skills in the Academic Tuition Center. It is your favorite teacher, Kaumaji Mwasa. In this video, I'm going to look at the limiting reactant. So we have to understand that there is excess reactant and limiting reactant. So a limiting reactant is a reactant that is used up in a given reaction, or it is used up completely in a chemical reaction. And at the same time, it determines the amount of product formed and the reactants to be used in a chemical reaction. Now, how do you determine the limiting reactant? One is to balance the chemical equation. You have to ensure that the chemical equation is balanced. Then two, you have to convert the amounts into number of moles. That is the masses given, the concentration given, and as well as the volume given. These have to be converted into number of moles. Then three, divide by the coefficients. The coefficients are gotten from the balanced equation. Then four, reactant with a smaller number is the limiting reagent. So you compare compare after dividing with the coefficients. The reactant with a smaller number is the limiting reactant. Let us look at this example. 2.0 grams of pure magnesium ribbon reacted with exactly 100 cubic centimeters of 2.0 moles per cubic decimeters of hydrochloric acid. So we are given 2.0 grams of pure magnesium ribbon to react with that quantity of hydrochloric acid. So in order for these to react, first of all, we have to ensure that we write a balanced chemical equation. So we have a balanced chemical equation, which is magnesium reacting with hydrochloric acid to give us magnesium chloride and hydrogen gas. Then after writing a balanced equation, then we get the number of moles for magnesium. So say a number of moles is equal to mass divided by the molar mass. So we are given the mass of magnesium as 2.0, then the molar mass for magnesium, which is 24.0 grams per mole. So from there, we cancel out the grams. So from 2.0 we cancel, and as well as from 24.0 we cancel out number of moles. So there we just remain with the moles. Then when we divide this, it will give us 0.083 moles as for magnesium. Then we look at the other one we get for hydrochloric acid. So number of moles for hydrochloric acid is equal to concentration times volume, where the concentration is given as 2 molar. Then we have 100 cubic centimeters, which is divided by 1000 by converting it into cubic decimeters. So there we are going to have 0.2 moles as the number of moles of hydrochloric acid. After calculating this, we now divide by the coefficients from the balanced equation. So we write our balanced equation. So when you look at the balanced equation, from the balanced equation, we have 1 mole of magnesium reacted with 2 moles of hydrochloric acid. So we are going to use that information in order to get the values which we want. So we'll say for magnesium, 0.083 moles divided by 1 mole from the balanced equation. So we cancel out the moles, and then when we divide, we are going to have the actual number, which is 0.083. Then for hydrochloric acid, we have the number of moles that were calculated to be 0.2 moles divided by 2 moles from the balanced equation. We cancel out the number of moles there, and it is going to give us 0.1. So from there, it is very important now to look at the values that you have and compare them. So a reactant with a smaller number is a limiting reagent. So when you look at what we have, magnesium has got a smaller number as compared to hydrochloric acid. So magnesium is the limiting reactant.